Hello, hello. It tells me I'm live. I will take that as given. Um, it is April 3rd. It is still the year 2025. I'm doing this about once a week now. So, why am I here today? Why? I am here today because of what has been happening weather-wise in the U.S. Southeast, uh, from about Texas east of there, and actually more like the U.S. East, certainly north of the southern states up into Illinois, right? Ohio. That's very nearly the eastern third of the country, say east of the Mississippi, as a benchmark. Midwest to the Atlantic Ocean. So uh, it's important to make that distinction because there's something about that part of the world that is making a particular problem for those people living in that part of the world. And I'm going to talk about that in a moment. What is happening in the US Southeast that is of concern to me today? They yesterday, the second Wednesday, they had a storm outbreak that uh, meteorologists have been hammering on about for like 5 days before it actually happened, um, as the worst storm to hit that region of the country in 100 years. And then later on, when the day got closer and the storm was rolling in on Tuesday, they were saying things like, "We're going to see the worst flooding in 1,000 years." That's not the way they say it. They say it's a 1 in 1,000 year storm. That's how they say it. That's a probabilistic statement. So why am I on here and why do I care? Well, bad weather, right? That's global heating. What's the tie to global heating? Well, the tie to global heating is that you can't have those kinds of storms without energy. These are energetic storms. That's what they are. They are thunderstorms, large hail, and we're talking hail like the size of softballs, right? Thunderstorms with lightning, large hail, heavy rain, really heavy, heavy like hurricane force rains, hurricane force winds. So just horizontal across the ground, what we call straight line winds, hurricane force, straight line winds, horizontal to the ground, and cyclonic winds, which we call tornadoes. They evolve. They go through, this mesovortices and supercells, and then finally they drop a tornado. But they're all rotating wind fields. They finally give rise to tornadoes, and 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 the tornadoes, when they are finally constructed and when they finally drop, the tornadoes themselves are violent, long track, and long lived. Long track means they're on the ground for a long time, which is not common tornado behavior. And long lived means they're on the ground for a long time, for a long way. Okay. Tornadoes that can be on the ground for 15 minutes, 20 minutes, and they're moving so fast that they cover a long trajectory before they finally dissipate. Again, the high winds at surface level are blowing these tornadic storms across the landscape. And when the tornado finally drops, in addition to spinning, it's got a wind pushing it downfield. And so this is all energy. That's what I'm trying to say. I'll give you the list again. These are energetic storms. They have thunder and lightning. They have hail, large hail. They have torrential rains, like nothing you've ever seen, unless you've been in a hurricane. They have heavy, high, straight line winds. And then they have rotating cloud bases, which give rise to tornadoes, which can be, again, highly energetic, have long tracks on the ground, and can be long lived, right? Everything that whole bullet list is energy. Energy. And where does the energy come from? I wonder. Where could the energy be coming from? Where do we have energy in the system? How has the system changed that suddenly it has all this excess energy? And I wonder, let's think, let's look around. What is happening currently in the weather and in the earth system that could cause all this energy to suddenly be available to these massive storms that can cover 8, 9, 10 states at a time, right? And last for 3 days and drop 20 inches of rain and drop 20, 30, 40, 50 tornadoes and long track violent storms and they hang around for days and flooding and thousand-year storms. And I wonder where all that energy could be coming from, because that's a lot of energy, right? To create something like that big. You can't create anything that big. And if you did create something like that, you'd need a lot of energy to do it. I wonder where that energy is coming from. Well, you know what I'm going to say, right? It's global heating. And the relationship between, it's complicated. And I understand why nobody goes into this. I understand why the meteorologists in particular don't go into this. The planet is heating up. And I say the planet because it's the atmosphere, the hydrosphere, the oceans, right? The ice is melting. The planet is heating up. And this is happening because of the greenhouse effect being enhanced by carbon emissions from fossil fuel consumption. We're all on board with this, right? We all get this part. Global heating is heating. Heat is energy. The energy can do work. This is like physics 1A, okay? What kind of work can the heat do? Well, it can melt ice. That's a lot of work. Take water, even in ice form, has a massive specific heat. So transitioning from solid water to liquid water, melting ice, takes an enormous amount of energy. Taking liquid water and boiling it to get water vapor takes an enormous amount of energy, right? So and you say, well, the energy is consumed. But also in a different part of physics 1A, you learned about the conservation of energy and the conservation of matter. So that when energy is doing all this work, it's melting the ice and then it's boiling the water and then it's lofting up the water vapor. When it's doing all that, the energy isn't lost. And that's the key takeaway. That's it. That's right there. That's the money shot right there. The energy isn't lost. So when you heat the oceans and then they evaporate, that water vapor that came out of that liquid ocean, and now it's invisible, right? It's invisible, but it contains massive amounts of energy. They explained this to you in physics 1A, if you took it, that the energy is now in the water vapor. It left the liquid water and it lofted up as water vapor, and the energy in the hot water went into the hot water vapor. Oh, just as an aside, okay, I'll get to the aside in a moment. So the water vapor is hot, and in many meaningful ways, all that energy in the ocean can now be in the atmosphere. At least, the top surface of the ocean, which is, of course, very deep. So there's a lot of energy for use. But the top hottest water in that ocean ended up in the atmosphere. That energy can do work. Now, to do work, the energy must be released. And the way that energy in water vapor in the atmosphere is released is through the final thing that water can do when it's in the atmosphere, which is to condense. It's a water vapor, which is invisible. It starts to condense as clouds, which you can see, but that's water vapor that was invisible. And if you watch time-lapse video of cloud formation, you'll see that clouds actually just emerge out of nothing. They're not emerging out of nothing. The water vapor was in the atmosphere. It was hot, but as it cooled, it condensed, and the condensed water vapor, which is invisible, condenses as water droplets, liquid water, which is visible, just like you can see a stream or a river or the ocean. You can see the water. So when it's in the sky and it's visible, having emerged from an invisible water vapor, it's called a cloud. When it makes that transition from vapor back to liquid, because remember, it was liquid in the ocean. So when it makes the transition back to liquid, clouds and rain and even hail, believe it or not, it releases that energy. It took the energy out of the liquid water to become water vapor. And when it condenses back into visible water as a cloud and as rain and hail and everything else associated with clouds, it releases the energy back into the atmosphere, back into the oxygen and the nitrogen and everything that's in the atmosphere. And that energy, once it's released, gives you these storms. Let me go through that again quickly. This is the deal. This is the entire deal. This is the thing everybody must understand now, and that nobody understands. Physicists understand it. They may not remember having ever taken physics 1A, but they actually do understand this. They understand phase changes, okay? They don't think about it. They're off doing whatever, string theory, right? But they remember sometimes physics 1A where they learned about transitions, phase shifts. And if you ask them, so what happens to the energy? They'll say, oh, well, it's still there. Here's what happens, okay? We release CO2 into the atmosphere. CO2 gas, carbon dioxide gas, is a greenhouse gas. It traps heat, energy. The heated air transfers some of that energy through contact to the oceans, which have a huge specific heat. Water can hold a lot of energy. Energy moving from the atmosphere where the greenhouse effect is found into the water. The water has a high specific heat. It absorbs a lot of the heat from the atmosphere, so we don't have to deal with it. There's a feature. That's why it's nice to have a water planet, right? It absorbs all the excess energy. Woohoo! Eventually, though, that heat in the liquid water causes evaporation, and the evaporation transfers the heat to the water vapor, which is now in the atmosphere. When later on, that same moisture in the atmosphere as dissolved water rains out, which takes about 9 days. So it doesn't travel very far. The energy is now in the atmosphere. Now, all the storm features that I mentioned, and I'll mention them again. Rain, other forms of precipitation like hail, straight line winds, tornadic winds, okay? Everything you associate with these massive storms comes about through a process called convection. Massive thunderheads, huge hurricanes, huge tornadoes. These are all symptoms of convection. Convection is when wind, rather than flowing across the land, which is sensible wind that we can feel. Yeah. Oh yeah, the wind's blowing. Okay. Sensible wind blows across the ground. We cannot sense when wind is moving up and down because we're not up there. Birds probably notice. And you can notice it. You do have an instrument to notice when there is convection happening, and that's with your eyes, because you can see big thunderheads being built up as the air races upwards because it's full of energy. Where is it getting the energy? From the rain. And where did the rain get the energy? From the water vapor. Where did the water vapor get the energy? From the oceans. And what's driving this entire thing in the U.S. Southeast is the Gulf of Mexico is hot. Yes, I'm calling it the Gulf of Mexico. The Gulf of Mexico is hot. Why is it hot? Because of global heating. Oh, it's hot because of sunspots. No, it isn't. It's hot because of global heating. All the planet's oceans are hot, by the way. This is a big problem. And what we're seeing right now happening in the lower 48 U.S. states is actually happening in many places. There are many places that are getting torrential rains like they've never seen before. And the whole process starts in the ocean. And the oceans have never been hotter. Certainly not in the instrument record of humanity. But we know that they haven't been this hot in 20 million years because the CO2 levels in the atmosphere were dropping over that period of time, and the Earth was cooling. The oceans were never this hot before now. And why are they this hot now? Because we are enhancing the greenhouse effect. We are adding CO2, methane, some other stuff to the atmosphere through the combustion of fossil fuels here on the ground with our cars and our jets and our trains and our cargo ships and our cooktops and our heating our water and generating electricity and all the industrial processes that use natural gas and everything else to create heat, forging metals and working with alloys and all that stuff, all this heavy industry uses fossil fuels. And so we have been very busy progressing and fastering and biggering and doing all the things and inventing penicillin and inventing the internet and waging war and all this kind of things. We've been so busy being clever little monkeys that most of us haven't noticed that we've been increasing the amount of greenhouse gases in the atmosphere. Most of us, of course, wouldn't, because you can't see it, you can't smell it. You can only perceive the impacts. And we are now beginning to perceive the impacts. Back when James Hansen first gave testimony to Congress, what was it, 88 or something like that, 1988? He was warning, oh, yeah, the consequences of what we've been doing will be seen in the future by future generations. He's still alive. He's an old guy. He's retired, but what wasn't future generations. He even wrote a book recently. It's the second one. My wife can tell you what it is. Storms of My Granddaughters or Grandchildren. What is it? Storms of My Grandchildren. Yeah, Storms of My Grandchildren. He's an old codger like me. He's got grandkids. And so he's a very thoughtful, loving person. He loves his kids and his grandkids. And so he wrote a book, Storms of My Grandchildren. And he's predicting all the terrible things that will happen future generations because of what we're doing now to increase the greenhouse effect and heat the planet and heat the oceans and all the storms that are going to come, except they showed up yesterday. There you go. He should retitle his books, Storms of My, well, I guess his grandchildren are still born. But the implication that this is going to be in the future is now silly. It's just silly. The future, it's happening now. It's happening now. It's happening in the U.S. Southeast. They just got a series of storms that originated in the Gulf of Mexico, where the water is hot. And you got a lot of evaporation. And all that energy went into the atmosphere. And then it went a little ways inland and it's dropped as rain. And in the process of dropping as rain, it released all that energy in the atmosphere where it came from. You see how this just keeps going around? Because it does. And so that energy led to massive amounts of convection, which creates all the terrible things, including things like tornadoes. So they had an outbreak yesterday. And as I said, the meteorologists were warning people for days. This is going to be the worst. You've never seen anything like it. And I was on YouTube, and I was watching some meteorologist talking to the news anchor. You know how they do, how they banter back and forth a little bit. And the meteorologist was saying, yeah, this is going to be historic storm. And the news anchor was like, you kind of see him like, what's that mean? What do you mean historic? We don't get historic anything around here. We're just podunk, rural USA. We don't historic. What do you mean? He says, yeah, we've never seen this before. Really? Well, that's alarming. Well, yes, it should be alarming because it is. And how do they determine these things? How do they determine something's going to be historic? Well, if a storm is coming ashore from the Gulf of Mexico that because of computer models is going to drop anywhere from 15 to 20 inches of rain, then you kind of say, when was the last time that happened? So you go back and look in your records for the region, the county, the state, whatever, and it's never happened before. Then you can say, well, that's telling. That tells you something about this storm. This is amazing. Now, he's a meteorologist. He's not going to do any of the stuff I'm doing right now. And plus, the stuff I'm doing right now takes a lot of time. So he's just going to say, yeah, it's going to be a historic storm. And the anchor's like, historic storm. What does that mean? People don't know what that means because we are off the edge of the map, folks. We have left the map. We are no longer on the map. So it's kind of impossible for the meteorologist to say something like, well, it's going to be like that storm we had in 1995 or the storm that we had in 1923 or something like that, because it's It's more severe even than any of those. So, we've run out of ways to compare these things to anything that we could possibly understand. Now, this is becoming a common problem. The inability of meteorologists, and also, I have to say, climate scientists, although James Hansen is now recently one of the exceptions to this general rule, the inability of communicators, science communicators, to find appropriate language to communicate to listeners that they are fucked has become a problem. When Hurricane Helene passed out of the Gulf of Mexico, crossed the Florida Panhandle, crossed several states, and then stalled in the western part of North Carolina, I knew that was coming because I pay attention to influencers and science communicators on these topics. So they were saying, this is going to be amazing. This is going to be historic. This is going to be terrible. When Hurricane Helene comes ashore, it's going to be absolutely ruinous. We're going to get 20 inches of rain. We might get 25 inches of rain. And I was like, well, that's going to hurt. That's going to leave a mark. But then when Hurricane Helene came in and it did exactly what they said it was going to do, the people on the ground in North Carolina, and particularly Western North Carolina, they basically, anytime any newscaster talked to the people, their story was, we didn't know. We didn't know this was coming. We didn't know this was possible. What just happened? And then they became conspiratorial, which is what these people tend to do. That's why they're living up in the mountains where they don't have to see anybody because they can be as wild-eyed as they want to be. And then they were conspiratorial. And then it was the Biden administration did something, whatever that was. And then it was sunspots. And then it was something else. HARP. HAARP. It's a government project from the 50s. Okay. It was HARP and it was something else. I don't know who knows what they came up with. All of it unhinged, right? Because they got no warning that they could understand. They got no warning they could understand. That's key. It's never happened before. They didn't know what to make of it. And then they got no help. And then the fifth point, they got no explanation. All of this is failures of communication to some extent because we don't have the language to communicate how fucked they were. And they remain fucked to this day. This storm that just went through here yesterday and is continuing today, it is raining on Western North Carolina again. And these people are now living in tents and camp trailers and in the back of their pickup truck under the camper shell. And they're getting another 20 inches of rain. They're still cut off from civilization. They still don't have their roads and bridges rebuilt. That's still a 10-year project that hasn't even started yet, probably in most cases, hasn't even begun. And where's the funding going to come from? They're done. They're toast. They're fucked. And we have no language. We just don't possess the language. The words, I'm using the word fucked. I don't know what else I can say. We can't communicate the scope of the disaster in ways that people can comprehend. That's it. That's our current problem. Now, we can use storytelling and we can use narrative. So not words, not adjectives, descriptive words. We can instead use narrative, storytelling. So the way I explain these people's situation, and I've done videos and I've explained it to them in videos, long form videos, right? Narrative, storytelling, goes something like this. You are in a dangerous place. The place where you are is going to become increasingly dangerous. And here I'm talking about the US Southeast and the Midwest, all the way to the Great Lakes, all the way to the Atlantic Ocean. All those people. What is that? 200 million people? 150 million people? Probably something like that. 200 million people. The place you are is dangerous. It will shortly, meaning in a few years, be demonstrably uninhabitable. The activities that you currently engage in on a daily basis will become difficult and eventually impossible. You won't be able to survive there. The weather is going to try to kill you every week. And in many cases, it will succeed. This is a story I'm telling. I'm not saying, oh, wow, you're basically fucked, because that doesn't even do it. I have to tell the story. You are near the Gulf of Mexico. It is hot. It is going to continue to loft these very hot, very large columns of water vapor into the atmosphere. And the prevailing winds are going to continue to sail those over the part of the country we're talking about. And they will continue to drop enormous amounts of water because that's what they do. And when they do drop their water finally and they release the heat back into the atmosphere, the massive amounts of convection that will be created by that heat of phase transition of water back or water from vapor back to liquid, that phase transition and the heat that's released from it will create convective storms that you cannot even comprehend because they've never been possible before. Because we just fucked up the planet like recently. And when they say things like, well, this was a 1 in 1,000-year storm, okay, or a 1 in 100-year storm. They were saying this one yesterday was a 1 in 1,000-year storm. That's not right. That is not the narrative we should be talking about. The conditions that exist right now in the Gulf of Mexico have not been present in the Gulf of Mexico in 20 million years. This is not a storm that arrives with a certain probability, and the probability is rare. But you could have another one in another 1,000 years because it's a 1 in 1,000-year storm. So you have to kind of imagine that maybe every 1,000 years or so you get another storm like this. But that's not what's happening. Hurricane Helene happened 6 months ago, right? And this one happened yesterday, and it's a 3-day storm, and it could easily come back and do the same thing next week. And these kinds of storms have been pummeling this exact region for 6 months. 6 months. It's the same story week after week after week. And they've even begun to notice. They've even begun to say things like, well, we just had one of these last week. Well, we had 2 tornadoes yesterday, and a month ago, we had one that just missed our town. And they're beginning to kind of notice something's going on. And then they're going to get conspiratorial. Oh, it's the Biden administration. Oh, it's the sunspots. It's the El Nino. It's the La Nina. It's something else. Aliens, HARP, Jewish space lasers, right? Yeah, they've even blamed some of this on Jewish space lasers. They don't get it. They can't comprehend it. And the narrative is, you are living in a dangerous place. It wasn't dangerous 30 years ago, but it's dangerous now. And if you can't comprehend what has changed is Earth dynamics, and the system is being spun up with energy. And where's that energy coming from? It's coming from the oceans by and large, and the oceans and everything else is getting it from global heating. Okay, the atmosphere is getting hot. And why is the atmosphere getting hot? Well, it's not getting hot because of HARP. It's getting hot because of CO2 emissions from the consumption of fossil fuels. And when the CO2 emissions collect in the atmosphere, as they have been, and we're up to like 427 parts per million, although we won't know in the future because they're shutting down the CO2 lab on Mauna Loa volcano. Thank you very much, Elon Musk. We're just going to have to guess that it keeps going up, people, because they're not going to tell you it's going up. They're not going to show you the numbers. You're just going to have to remember it's going up. Every single year it goes up. So just keep that in mind. Because we did that, and because we're still doing that, and because we will continue to do that, these storms continue. They come from the Gulf of Mexico. That's because the Gulf of Mexico is hot. The Gulf of Mexico will never not be hot. For millions of years, it will never not be hot. This never goes back. In fact, all it does is get worse. The heating of the Gulf of Mexico and all the other oceans only gets worse. The heating of the atmosphere due to climate change, CO2 emissions, only gets worse. The amount of heat in the atmosphere only gets worse. It never ratchets down. It just ratchets up. And in fact, the rate at which it is increasing, and the rate at which all these things are increasing, the rate is increasing. It's not going up as a straight line. It's going up like a moonshot. And the future is grim. And we're already seeing these places that are clearly in the crosshairs of global heating, clearly in the crosshairs. And these people need to get out. As simple as that. Just they can't be saved. They can't be saved. What else can I say? They cannot be saved. They're living in a place that's dangerous. It is dangerous, and the danger will get worse until finally they can't live there anymore. Well, you can die there. You can eke out an existence there, but you're not going to have a job. You're not going to be driving to work. Your kids aren't going to be going to school. The schools will be flattened by the winds and the tornadoes and the hurricanes and everything else. And maybe you'll have enough land to, have a garden and you grow potatoes and corn and whatever, okra, whatever. And then, you're living like Stone Age people. And the bridge was washed out and they're not burning the bridge back and you're kind of done. So yeah, you can live there for certain values of the word live there, but they're finished. It's uninhabitable by and large. And civilization will abandon them. Civilization has abandoned those people who were living and are stuck living. You can't get to them except with a helicopter in Western North Carolina. They're done. They're done. If you want to continue to live there, then you can, whatever, Stone Age existence, okay? Because they're not going to fly you in groceries. You're just going to have to survive somehow because you don't have your roads, you don't have your bridges, and you won't have fuel for your cars, and you're just going to be stuck. Good luck. And that just came, yesterday, we just had more of the same. And I wouldn't be surprised if those people living in FEMA tents in the western part of North Carolina just got another dose of rain. Wouldn't be at all surprised. Now, the rain from the last storm yesterday has not arrived. I mean, not rain, the floodwaters. Floodwaters take a day or day and a half to collect. They're up in the hills and they start coming down. And if you were up in the hills when the rains were coming, you'd see these little rivulets of water running down like someone, turned a bucket upside down in water, and it's going down the hill and carrying the leaves with it, and you'd be walking along in those hills, and every few feet there'd be a little rivulet going down to the stream down there, and pretty soon you'd be hearing the stream rising and going through the trees. You're like, wow, we must have had a lot of rain here. And sure enough, and the stream, well, further downstream the rivers are swelling, and further down from that the bigger rivers are swelling, and pretty soon all that rain takes a day or two. It makes its way down to civilization, which is not up in the mountains where the little streams are and the little things, but civilization, the big towns and the cities and the bridges and all that are down in the bottom where the rivers are. And pretty soon all that water comes down, and a day and a half later, 2 days later, you have monumental floods that are, once again, as we've frequently seen, washing away entire communities, washing out the bridges, undermining the embankments of the bridges, washing them out, overtopping the dams and the weirs and the flood control structures, overtopping the levees and the berms and the dikes, water escaping from all of this control infrastructure, blasting it all away, even blasting out the flood gauges. Flood gauge shows the water coming up, and then the flood gauge shows nothing because it's now in the ocean. It got washed away. So this is what these people are facing. This is what's happening to them. And for some people, they'll be able to recover, right? But if your community was washed away, and now we're in the land of unintended consequences, right? It used to be these were small events, and maybe it was a couple houses got washed away, but the community was okay, and you could still go to the shopping center and the Starbucks, and maybe your job was the next town over, so you could still get to work, but the bridge was out. So, you had to go stay with your cousin who lives 5 miles further down the road, and you stayed there and you went to work, and finally they fixed the bridge because they only had one bridge to fix. And then you were able, it took them a month, right? You stay with your cousin. He's got a travel trailer. You go to and from work, and the work is fine. And they're all like patting you on the shoulder. Tough deal. You got flooded out. And then they rebuild the bridge, and then you finally get back to your normally scheduled life, right? because it was just you and just your 3 or 4 houses on your ridge top where you were living, and there's just the one road and the one bridge, and it got washed out, but everyone else could come to your aid. Okay, well, what happens when the flood is so big that it not only washes out your bridge up up the mountain to your house, but it not washes out the entire road for 20 miles? And then it washes out your cousin's house, including the travel trailer. And then it goes down further and it washes out the next town, destroys about half of it, including the place where you used to shop and the Starbucks and the everything else. And then it goes down and it floods the town where you actually work, where your job is. And pretty soon they've got water damage and they close until they can get some money from the insurance company to repair and get back to business, which can take a month or a month and a half or 2 or 6, right? And so when these storms were little, you could tell yourself a story. This happens all the time. I remember back 1978, that bridge washed out once before. Now it's a better bridge, but it's still washed out. Bridges wash out all the time. Rah, 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 yammer, yammer, yammer. 1978, 1962, and whatever. And then yesterday happens. And before that, Hurricane Helene happened. And after this one, yesterday, next week will happen. And now that's the pattern. And everything you thought you knew, that sometimes a bridge washes out, but then you go stay with your cousin in the travel trailer, everything you thought you knew and you had a handle on doesn't work anymore. And it's going to take these people a while to figure that out. But they're beginning to figure that out. I mean, even a monkey can put dots together eventually. So they're starting to notice now, well, this has been happening a lot. Wow. I got flooded out last year on another ridge, and I moved into this house and it just got flooded out this year. Now I don't know where I'm going to go. There's a pattern here. And you may say, well, I just had bad luck. But if you're paying attention to the news and you're paying attention to the weather report, it's not just you. It's half the state. It's 3 states. It's 9 states. And what's happening? And people will always say, well, we've had floods before. That bridge right there it used to wash out once in a while. It was a little bridge. Now it's a big bridge, and that's still washed out. That's a little alarming. But hey, that bridge has washed out before. And you're always doing this normalization thing and remembering what used to happen. And your granddad told you stories about that bridge and about living on this hill. And what you don't understand is, because you just can't fathom it, is that your bridge washing out is not the only one. There's 73 other bridges that washed out the same night. And the road where your bridge just washed out is gone for 8 miles. It's gone. The asphalt has vanished. And 2 other bridges and culverts and other things that, the infrastructure on that road, they're gone too. And also there's 4,700 trees that have been blown over into the road and blown over and onto and washed up into bridges and took the bridges down. And you see your little bridge and you can't cross your bridge with your car, and like, how am I going to get to work? And you don't understand. You still don't understand what happened to you. 3 states got wiped out for certain interpretations of the word wiped out. And it's going to take months, if not years, to do the repairs. Except that, oh no, this is going to happen again next week. If not next week, a month later. And if not a month later, next year. And you can't recover. And no one understands that this is what's happening, because they can't comprehend it. We collectively, humanity collectively, is in a very dangerous place. The Earth system that we have always thought we understood, and on a regional, limited basis, your house, your community, maybe your city, that river, this bridge, the dam upstream, this forest, this croplands, the things that you thought you had your head wrapped around. This is not the scale at which this is happening. Your bridge isn't the only one that washed out. Your stream isn't the only one that destroyed civilization for 70 miles downstream. The cloud burst that you got where it dumped 20 inches over 48 hours. That wasn't the only cloud. And you're not the only one who got 20 inches of rain in that period of time. The scale and the scope of these mounting and accumulating disasters is incomprehensible. And that's a word that is not going to enter this conversation because people don't think about what they cannot think about. I'll say that again. People can't think about what they cannot think about. If something is incomprehensible, then by definition, you cannot comprehend it. You might need someone who can comprehend it to come along and tell you, you need to sit down. I need to point something out to you because I don't think you're getting it. And that's not your fault, but it would be my fault if I didn't explain it to you. Something is happening to you that for the average person, all of them good people, for the average person is incomprehensible. Not because the average person is dumb, but people cannot comprehend things at too big of a scale. Planet-wide phenomena, large region, continental phenomena are incomprehensible to people. That's just how it is. You would need special training to comprehend what I am telling you. What I'm telling you is the place, what you cannot comprehend, but are beginning to sense is that the place you live and work and go to school and have your home and have your family and have your everything is becoming uninhabitable for the purposes of all those things. You can't stay here. But we used to have storms. Not like this, you haven't. And not like the ones that are coming. The ones that are going to come are going to be worse. Well, that can't be true. Oh, yes, it can. It can be true. You're seeing things happening to you that 20 years ago, people would say, well, that can't happen, but it did. And it's happening regularly now, and it's happening all the time, and it's happening everywhere. Pretty soon, you're going to see worse things because it can get worse. And because we're doing nothing to stop this, because we can't really. I mean, I'm not saying there's a way we could do it. I'm just saying we are not doing anything to stop this. We can't do anything, and we're not doing anything. Both of those are true. Because we can't do anything to stop this, it has to get worse. And eventually, you're not going to recognize these places where you currently live. You won't be able to recognize them. The landscape will be altered. And the risk is, and the likelihood and the certainty is that these landscapes that prior to now were perfectly hospitable for most of the things people want to do, these landscapes that have been habitable given certain expectations for habitability, like occasionally you get a tornado, occasionally you get a hurricane. These landscapes that were tolerably dangerous are becoming and will continue to become increasingly dangerous until they very silently and without any discussion cross a threshold of what do you want to call it? Lethality? Where you cannot live here. You can die here, but you cannot live here. You can disappear here. You can be demolished. You can be drowned and washed out to sea here, but you cannot live here. And therefore, you must, if you want to live somewhere, then you must leave. And I'm telling you, this is completely incomprehensible. The fact that landscapes can change is incomprehensible to most people. They don't even know how to start thinking about that. Climatologists understand it. Geologists understand it. Archaeologists understand it. We paleoclimatologists understand it. We understand that landscapes change. Well, hey, we used to have ice here. Now there's no ice. Now we have whatever we have. And where'd the ice go? I don't know, but it's not here now. Ah, but it could come back. Well, that's true too. Okay. Landscapes do change, but not in a person's lifetime. Landscapes do change, but not so far in our civilization, right? What, the last 10,000 years, 8,000 years ago to now, 8,000 years, BCE to now. Uh, Landscapes change, but only over geologic time until now. And what's the difference between how landscapes change over geologic time versus how they're changing now? And the difference is we are absolutely wrecking with a wrecking ball the Earth dynamic system. The Earth dynamic system, the big engine in which we actually live. We are part of this engine that's slowly turning all of its gears. It gives you the weather and it gives you the seasons and all these things that happen. That Earth dynamic system that moves imperceptibly, but moves nevertheless. That system, we have taken a wrecking ball to it. Now, it can't disappear. It's stuck to the planet, gravity, right? So it can't disappear, but it can change, and it can change out from under us. If you were sitting in a chair and you had a saw in your hand and you were down here under the chair cutting off one of the legs of the chair, then at some point you'll succeed and the leg of the chair will fall off. And what's going to happen to you? You fall over. You were changing that system. And normally when you sit a chair down that's got enough legs and they're all the same length and you can sit down in that chair, it's comfortable. It doesn't move around. It doesn't go anywhere. But if you take a saw and you start cutting off one of the legs on that chair, that's not going to work. You took a wrecking ball to it, essentially. And you destroyed the dynamics, the physics of that chair. And without four legs, it fell over. And the Earth dynamic system is falling over. It will become something else. Probably after we're gone or after we've been depleted, essentially gone. The Earth dynamic system will eventually settle down into some other dynamic. It will be ice-free. The sea levels will have risen 270 feet. It'll be warmer. The heat we're seeing in India last week, 123 degrees Fahrenheit, that will become fairly normal in many places. It will be tropical. You'll have rains every day, 300 days a year, pretty much, maybe even 360 days a year. You'll have rain. You'll have seasons, but you won't be able to tell even that a season has changed. Maybe the winds blow from a different direction, different times of the year. Maybe the rains are a little colder. Maybe they are a little less frequent in some time of the year. Maybe you'll have a rainy season and a dry season, but they'll be almost the same. The Earth dynamic system will find another dynamic, and it won't look anything like the one we have now. For some species, like tropical species, it'll be fantastic, but it won't be fantastic for us because we're not a tropical species. Yes, there are humans that live in the tropics, but they have an antagonistic relationship with the tropics. They're constantly pumping water and they're constantly running away from floods, and they have their houses up on stilts, and they live in small villages, and the forest, the jungle is constantly encroaching, and they're cutting the trees down, they're hacking them back, and they're defending their croplands from beasts and trees and floods and serpents and scorpions and everything else. So they have this antagonistic relationship with the jungle and the rain and the earth system around them, and they eke out an existence in tropical areas. You can do it. You can certainly do it, but it's hard. It's a fight. It's a constant fight. Banana trees coming up in the middle of your living room, and it's a constant fight when you live in the tropics. Well, we humans evolved on the savanna. We're bipedal and we're runners. If we evolved in the jungle, we would be more like chimps. We'd be brachiators. We'd have long arms with curved fingers, and we'd go into trees because the ground is so full of vegetation that you can't walk. You certainly don't walk upright. You would walk on all fours, right? Like leopards and tigers and whatnot, tapirs, those kind of things. We evolved on the savanna. and we were bipedal and our hands were free, and we invented spears and arrows and all this stuff, and we hunted the big game out on the savannah. We are not tropical species. We evolved on the savannah. We made tools to hunt animals on the savannah. We ate large animals, lots of meat, and then we wore the skins. Okay, we evolved on the savannah. The apes that stayed in the jungle don't do what we do. Chimps don't do what we do. Gorillas don't do what we do. They don't even try. They don't even come close. We evolved on the savannah where there's hardly any trees and there's low brush and there's big herds of animals, grazing animals, and meat, all you can eat. Buffet. We evolved on the savannah. So when the planet becomes tropical again, as is beginning to happen in the US Southeast, as the tropics expand their range from the equator, north and south from the equator, we mostly care about north. That's where most of the land is. As the tropics expand their range due to global heating, due to changes in the Earth dynamic system, as the tropics expand their range, we're going to find ourselves fighting nature to survive. Jungles, essentially jungles. And the storm troops of this transition are the hurricanes and the tornadoes. And they are going to announce the arrival of uninhabitable Earth. The jungles are uninhabitable for our purposes. You can't have roads. You can't have transmission lines for electricity. You can't have gas lines and water lines. Okay, you're living on the very skin of the surface of the earth. You get your water from that pond right there. You get your fish from that pond over there, and maybe you hunt birds and you steal the eggs, and you're in the trees and you're on the ground, and you can't dig because the water table is 6 inches below the surface, and your houses are up on stilts, and the hurricanes come across the landscape, and you don't have any manufactured materials. You're making your houses out of logs that you find nearby, and you thatch them with leaves, and then the hurricane comes through and it blows all that down, and then you pick it all up and you rebuild, and that's your life in the tropics. And that doesn't sound like Netflix, and it won't be, but that's what's happening right now in the US Southeast. The hurricanes and the rains and the floods and the tornadoes and the high energy storm systems and the heat coming off the Gulf of Mexico. These are all early warnings of a massive, unstoppable shift in the Earth dynamic system, where it's getting hot and the tropics are expanding and they're coming to these places. Now, we tend to think about heat as, oh, everything's going to dry up. Exactly the opposite will happen. Everything will be dominated by torrential rains. If there's any deserts, they'll be in the continental interiors, for example, in the wheat basket of the US. Those might turn into deserts because the and this is fairly typical, by the way. You can see this in Africa, where the prevailing winds blow in the moisture, but it can't travel over the land very far before it drops out. And so if you have a big continent like the US lower 48, you end up getting all this moisture injected into the system, but it rains out right away. And in the center, you might actually have a relative desert, or it might be savanna, small shrubs and grasses and herds of animals. And maybe you have that going on, but it won't look anything like it looks like right now. My actual prediction for California, where I live, is that we're going to be dominated by floods. It hasn't started yet, but it will probably happen. We're having heat waves right now, and my expectation is that once the Pacific Ocean gets warmer, see, we're not near a warm body of water. The U.S. Southeast is downwind and in the weather track of storms coming off the Gulf of Mexico, including hurricanes. So their fate is to become tropical first, and it's going to happen rapidly, and it's going to happen exactly as we're seeing it happen. Massive storms that dump water like you cannot comprehend. And the changes that are coming for them are going to be incomprehensible. Now, eventually, they'll come for California and Canada and Alaska and everywhere else, because the earth is becoming hot and the heat will continue and the tropics will move north. And eventually, everywhere on the planet will be essentially either tropical rainforests or continental interiors that are maybe a little drier. Maybe not. So that's how it is. And this is incomprehensible. But this isn't weather. And we don't, and everything I'm sharing here is a narrative. It's a story. It's a story about what's happening to us and what we've done to the Earth system and the changes we've set up. We did this. And I could say, yeah, you're basically fucked. I mean, I could say that. Well, most people will walk away not knowing what that means. Now they may walk away thinking, I think that guy's right. I feel that way. But they still won't understand why. It's a story, and it takes time to tell it. And you have to understand the history of continents and the history of this earth and how it used to be ice free and how it used to be mostly jungle. And there were, huge swamps and they laid down all these trees and bushes. And that's why we got coal and oil and natural gas. All of this was the vegetation of the world being dumped into the oceans on gigantic storms, hypercanes, and huge eroding rain epics that would just wash entire hillsides down into the ocean and bury the vegetation to be dug up later as coal. I mean, we know that these things happen because we have the coal seams. We can find the plants that got buried, and the coal seam could be 20 feet deep. What kind of an event was that? How many decades of events, how many centuries of eroding and washing and destroying did that take to build up a coal seam that's 20 feet thick? But that's what was happening. And that's going to come our way too. And when we find ourselves battling nature every single day, every day having to rebuild dozens of bridges and repave hundreds of miles of roads and rebuild, all the infrastructure that people require to survive every single day, service stations, grocery stores, and then the roads to get things to and from these places, law enforcement, hospitals, schools. And we just have to constantly rebuild these things, constantly bring them back so that we, modern humans, evolved on the savannah doing this, we can survive. We're fighting nature. We're fighting nature. This earth is returning to a system we haven't seen in 20 million years. These are not 1,000-year storms. These are 20 million year storms. The conditions that gave rise to these storms didn't exist 20 years ago or even 1,000 years ago. The Gulf of Mexico wasn't hot enough 1,000 years ago. It wasn't hot enough 100,000 years ago. The Gulf of Mexico hasn't been hot enough to develop these storms in this manner for 20 million years. That's the time scales we're talking about. And that's what we're going back to. These are not rare events. These are impossible storms. They're impossible until now. And we created these conditions where these storms are no longer not impossible. They're likely and they're inescapable. They're not impossible anymore. And you can think, well, we won't have another one like that. Yes, you will. Because the conditions never go away. The Gulf of Mexico never cools off. The winds never stop blowing from that direction. The clouds just continue to form and they release their heat and you continue to get the convection. And then you have a cold front and then you have a dry area and then you have a this and a that. And pretty soon you've got tornadoes. Pretty soon you got 20 tornadoes. Pretty soon you got 50. And that never stops. This is not your grandfather's weather. And just because this happened once in 1992 doesn't mean that these are rare. We've changed the system. These never go away. They only get worse. They're not rare. They become the norm. And when they do, people can't live there anymore. And this is incomprehensible. Worse things are coming. That can't be right. Oh, yes, that's right. We haven't stopped altering the Earth dynamic system. We're still pumping CO2 into the atmosphere. It still stays there. It's still heating the planet. The planet continues to get hotter. The rate at which the planet heats is actually increasing. And none of this will change for hundreds, if not thousands of years. We can stop burning fossil fuels tomorrow. Doesn't save those people living in the US Southeast. We've obviously already created the conditions for their untimely demise. Obviously. It just happened. It's been happening for 6 months. It's going to happen all year, and then it'll happen next year, and then it'll come again in the spring after that, and the spring after that. Except the only way that it changes is that it gets worse, more frequent, longer lasting, more rain falls at a time, not 20 inches but 25, and then not 25 but 30, and the lightning is just a continuous barrage. It just never stops. The sky is lit up with lightning constantly, like the lights were on. And the tornadoes come one after the other, literally 2 miles apart, 5 miles apart, one after the other. And you'll be sitting there wondering what happened. Global climate change, global heating in particular, is what happened. And it never stops, and it never goes away. And by the time things settle down, it could be 1,000 years from now, certainly hundreds of years from now, it all settles down. And when it does settle down, you're not going to recognize this planet. Certainly not big parts of it. You won't recognize it. And this is incomprehensible. And people have my sympathy. I understand it. You cannot comprehend it. But it doesn't matter if you can't comprehend it. That's what's happening. And maybe future generations will tell the story about how humanity was blindsided by all these changes they were making using fossil fuels. But I don't think they will. I don't think future generations will tell that story. I don't think future generations will understand that it happened at all. They won't have any context for what is happening now. There won't be any memory of it. There won't be any writing about it. There won't be any books about it. Everything will have been washed away. And people will spend so much time surviving and just finding food, shelter, and clothing that they won't bother keeping the books. They won't bother keeping journals and notes. They won't bother writing down history. There'll be another Dark Ages, just like we don't know what happened in medieval times in Europe during the Dark Ages because people were too busy scrambling around looking for food, clothing, and shelter to write anything. We call it the Dark Ages because we don't know anything about it. There's no light shown on what happened back then. We can kind of guess parts of it generally through archaeology, digging up ruins and digging up graves and looking at, the context of how people survived. And, because they weren't writing anything down, it was the Dark Ages. There's no illumination. And future generations won't know what happened to us. They just won't know. They may find a book someday that describes history up to the year 2025 or 2026. And then and then they don't find any books that describe anything after that because people stopped writing because people were too busy to keep notes. And if they kept notes, they kept them on a computer. And, where are the computers? We don't even know what those were. All the digital stuff, all the cloud stuff, all the stuff in the cloud servers and all the stuff on paper, and it's all gone. Future generations will have no idea what happened to us. They won't know anything about us. They'll find our cities. They'll find our, the vestiges of modernity, rusting and buried, and maybe they'll dig it up, and maybe they won't, and maybe they'll look at it and say, "Wow, that was amazing." The way we look at Aztec temples, right, or the pyramids, and say, "Wow, that was an amazing bunch of people. Wow, well, wonder what their daily life was like. Wow, wonder why they built this. Don't know. We'll never know. They're not around. They didn't leave any writings, and we can't decipher what they did, and we can't read what they did anyway." And no one understands these few pages we found, and we can't interpret the squiggles on the pages, and we just don't know. Because the earth is changing. And it's going to change us in the process. We're going to have a hard time living here. That's what's going to happen. And I have no recommendations except stay out in front of it. Think of it as a steamroller. It moves slowly, but if it ever catches you, you're done. So stay in front of it. Don't let it catch you. Impossible things are coming. Impossible things will stay. Impossible things will never go away. Get ready for the impossible. What kind of advice is that? Get ready for the impossible. That's all I got. All I have is a story. All I have is a story. Well, we're all writing this story, and you're going to have your part to play in it too. And you're going to have your message to yourself, and your message to your friends and family, and your message to your coworkers. And we need to start. We need to start writing this story. What's happening to us, and why, and how bad it could get, and how bad it will get. And impossible things are now likely. That's all I got. I'll be back when something else gets me all fired up. And stay out of the weather. And when the meteorologist tells you there's a flood coming, uh, take it seriously, because you are not going to believe what is coming. You're just not going to believe it. Everything you thought you knew is not going to help you. Don't forget to like and subscribe to the video. Like I say, I come back here every few weeks. There's a link in my description on this video to buy me a coffee, if you would, please. Makes me feel like I'm loved. And we'll see you next time. Take care and good luck.